Welcome back, everybody. Welcome back to the channel. So today we're going to be talking about how to add runtime type checking to your actual programming language. Now, this week's going to be a little bit of a weird week. So before we actually get into the video today, I first want to start off by saying thank you guys for everybody who watched the video. I actually wasn't expecting to see quite a few people interested in actually downloading the release and then wanting to not only do that, but test the language and send out bug reports. I think that's really awesome. You guys are awesome. So I just want to thank you guys for that. And if you haven't been reading the comments, the release is going to be scheduled for Wednesday. So this is our Monday video. However, on Wednesday, I'm going to make another video where I kind of explain the release, what new stuff is inside the language, so on and so forth. So this code that we're going over today is actually going to be in the release. I just added this yesterday, so you can look out for that as well. Newer things, though, keep in mind, are a little bit more skittish. Whenever I add new features, it's not really the best condition, right? Usually, when I do the second to third pass, is when things begin to get really good. So keep that in mind. But let's go into what it actually is. So runtime type checking is a very good way. It's a first step in making your programming language a little bit better when it comes to trying to figure out things, right? So what do I mean by that? So previously before, so like if I go to an example, let's see, in the primitives, so you guys know how I have like integers and where the hell's the file? So if I go here to primitives, so you guys know I have like primitives where I have like my standardized classes, longs, booleans, shorts, and all that stuff. So basically, this is a generic class. It's a really big generic class. Has a lot of functions. It's a generic class that the type of the actual value is going to be dependent upon the type of class. So if I scroll back down to ulong is going to be in uint64. So that's going to be the type of the actual field, but there's an issue with that. See, right now I have this parse function, and this is how you basically parse numbers in the programming language. Now, because all of these are longs, I just recently added double, which I also have to add here as well. But basically, this, yeah, here it is. Basically, this allows you to say int dots or int parse, and then you can pass in, 1, 2, 3, 4, and that works just fine, right? And typically this is okay. I mean, this parse function works good, but now that I have double added as another type to the programming language, it is going to cause issues when it comes to parsing this because you're basically only going to get integer values back. So I needed a way at runtime to check to see, what is the type of the current instance. So what I could do is, and this is what we're going to go over today, we can say if self, if you guys remember, self is a way to check the current instance. We can say self is, I don't have syntax highlighting for it yet, so that's why it's white. And then self is, and then double dot class, right? And then if that's the case, we parse the, we'll actually parse the string based on whether or not it's a double. Otherwise, we know it's an integer type class. So we're going to then, do whatever we need to do in there. So this is a very awesome way for us to do this. Now, the compiler is kind of stupid, so I don't have any advanced features where, like, if the current class is never going to be a double, in this case, if I'm checking the instance of the current class and it's not a double class, it's never ever going to be a double class in runtime. It's just physically impossible. So I don't have any checks yet to basically remove this if statement and just run the else statement because yeah, I'm working on that, but that is probably going to be V2 of this feature. So hopefully we'll see what that looks like in the future. Just for now, let's keep things pretty simple and let's see. So if I go back here, so we basically, I'm going to just go through a couple of examples. So the way it works is you can say array is, and then you can say underscore int 8, and then you could say underscore int 8 array, or whatever, but the type has to match. So if I'm checking if this is just an int 8, it's going to return false. So I have to put the array because obviously it's an array. You can also do some pretty interesting stuff as well. So like, let's say, I don't know, let's say you have a class of foo, right? and foo takes in, so let's say foo takes in a function, so fn, right? And then that function, func type function. So we can create a foo constructor, and we can pass in f type function, and then that's going to provide the function, and then we can do a check to see if f is, and then we can do function types. So at runtime, we could basically check to see if the function that we pass in is, I don't know, let's say like a var or whatever, and then you pass in an object, JECT, as like the second parameter, and then let's say it returns a var as its third parameter. If so, you can then say function is equal to f. Otherwise, you can throw an exception or whatever, throw exception or error, and you could throw an error and say, whatever you want, and that's pretty much it. So that's kind of how it works. You can basically, anything that's a type, you can check to see if it is that type. So you can do, var or, whatever. You can also check against function pointer arrays, because I actually have support for creating function pointer arrays in the programming language. So you can do that too. It's pretty awesome. So let's actually see how it looks. Now, I'm going to preface this with saying we're not going to go through everything because we haven't started going back to the compiler, and there's going to be a lot of stuff in there that you're not really going to understand. So I don't want to confuse you guys. So I'm going to keep it simple. We're going to look at how you parse this statement here. Then we're also going to look at how the virtual machine handles processing this instruction. And that's it. We're just going to keep it simple. We'll go over how it works in the compiler in a later video. So first, let's do the easy part. Let's go to the parser. So if I go up here to front end parser, and then go to parse expression. So when you go to parse expression, once it loads, then we can oh, it's a primary expression. Okay, so what you want to do is you want to put this inside of a primary expression, because this is going to be something that the user is probably going to be running into quite a lot, and it is going to return a value, so you do want to do that. So if I scroll down, this one, I pretty much copied the as formatting. So basically I have the is expression. We'll see where it's referenced in a second. But when it comes to parsing, we want to check to see if the next character is. If so, we encapsulate the current branch in a primary expression. Actually, let me go up here to give syntax highlighting, because this just looks very ugly. So that way it looks a lot better. So we encapsulate in a primary expression, we encapsulate it in a regular expression, and then a is expression. So this is a new type that I added to my my AST type list. So you are going to want to do that. And once we do that, and it's pretty much just like as. So basically, if the next character is a native type, meaning that if it's a var object, one of these native values, or if the next character is a parentheses, then most likely what it's going to be is a function pointer. So if it's either a native value or a function pointer, we want to basically just process it as it is. We don't want to add the dot class. So we just say parse utype. Otherwise, then we're going to assume it's a class. And for formality, we want to parse the utype, then expect the dot and then the class. And that's pretty much it. Fairly simple. And of course, I don't allow anything after it, because it's just going to look too weird. So if the user, for instance, I don't know, so let's say I strip this out into a variable. So I don't know, let's just say variable, or no, whatever. Then I strip this expression into a variable. You can't do like plus plus, because that doesn't make any sense. The only way you could do that is if you encapsulated it like this, but even that doesn't make any sense. But again, it's a programming language, so you just let the user do whatever the heck they want to do. So that's why I have these blockers here in the actual parser. So you can't do increment or decrements. You can't do a dot after it, because what are you dotting? It's returning a value. You can't do a left brace, because it's also not an array. So those are the blockers that I have. Now let's look to see where the is expression is actually being used. So first I have it in the increment. So if I plus plus a field, so basically what this is this is a case where I say, I don't know, plus plus f. Let's say f was actually a var or something, right? And if I plus plus f and then I check to see if that is this value, then that's basically going to allow us to do that. Now, one thing I will mention, and we're going to see this later on when we go into the actual compilation phase, this is check doesn't really run or execute the code to the left of it, meaning that what the compiler is going to try to do is it's going to try to resolve this expression at the compilation level. So if I know what the type of f is, then it's either going to be a 1 or 0. It doesn't make sense for me to offload that work to the runtime system to just slow down the programming language. So it actually does a lot of the processing at compile time. So just keep that in mind. Now, the only case where it would actually execute the code, let's change this code. So let's say, yeah, let's do this. So I'm going to say self. So if I go over self as, and then I'm going to convert this to an object, right? So now, as far as the compiler is concerned, we have no idea what the current type of the current instance is because I just converted it to an object. So I can then check to see if the self or the current object is of type foo of var. So var. And then basically what's going to happen is the compiler is now forced to execute the source code inside of this expression because it doesn't know what the type is at compile time. So it has to let the runtime figure out what the type is. So just keep that in mind. If any of you were testing and you were wondering why the code wasn't working or whatever, it's literally not going to execute the code if the compiler can just figure it out. So let's go back. So now if I go back to the parser, so for the plus plus, oh, this is after the expression. So instead of it being plus plus f, it's actually f plus plus. And then I check for the is after that. So let me go back. So basically, if the next character is an is, we just jump to the is expression. Now let's go up to the next one. So the next one is for left brace. So this is for parens, for array expressions. After like, I don't know, let's say you did like, f array at 0 or whatever. And to be honest, the user should not be putting expressions that evaluate to stuff inside of this is expression unless it's an object or some undiscernible type that the compiler just can't figure out. But if I go back, so if we have an is expression after an array, I do a checkup here for as already, where I check to see if the next token is not equal to as. I say branch is equal to get last sub, or I now added if the next expression is equal to is. This is used because I actually need to access the actual branch of the actual AST. So based on how this branch is created here for this specific expression, I need to do a certain thing. So that's why I have that. And then I check to see if the next token is in fact is, and then I jump to the is expression. So this one is for left paren. So this is for like if you, I don't know, um, did this pretty much, right? If I'm getting that correctly. Yeah, so this is a parent expression. So if you did this, then, you can also have an is afterwards. So I basically do the same thing here where I'm checking to see, if the next token is or as. And if it's not, then I assign the branch equal to the parent branch or the parent branch. And then I also add the is check here to go to the actual expression parse. Same thing for size of, same thing here, is check here. So if I go back up to, where's the next one? So this one is for new, so new also does it, same is check, and same is as check here. The next one is dot notation call expression, so same is check, and is as, this one is for base expressions, is check, is as, self, is check, is as, and let's see, this one is for U types. So I don't have the is as check here, but I just do a regular if statement here. And then finally, we have literal, where I just do, again, a regular if statement for checking for is. And that's pretty much it. So now let's look to see how this works at the low level. So I'm actually going to get rid of some of this clutter, and I'm actually going to just show you guys how this kind of works. So let's look at the code generation for this. So if I do a check simply where we have array is equal to new int 8 array of 10, and then I do a check to see if this is true, then what I can do is run the compiler, And whoops, I had this code here, so let me go back here and put in syntax. I actually just wrote my first neural net program. I'm gonna go over that tomorrow, but that's pretty cool if you guys would like to see a simple neural network written in the actual programming language. That is in the examples folder. It's a basic XOR neural network, but we'll talk about that on Wednesday. So if I try to recompile this, we should be good. Yeah. So basically, since the compiler knows that this is in fact an N8 array, there's no point in offsetting this code to the runtime system. So we're just going to basically be doing this, if true. And that's basically it. And because, again, my compiler is too stupid to realize that this is always going to be true, and just put the code that was inside of here outside the if statement. So haven't gotten to that point yet in the compiler. Hopefully that will be in a later release coming soon. But if we go to the actual bin folder, syntax ODF, I do a search for, what is it, the main function. You can see here that basically if I split this vertically, we move local of 10 or move a number of 10 into the EBX register. This is basically just creating the array. So we create the array, and then we pop that object off and assign it to the frame pointer +1, which is the address of this field. And then we just say move 1 into EBX, which is basically this source code here. And then we move EBX into CMT, and then we say jump if equal to 9. So we're basically just jumping to the end here. I don't have anything after this. So we're basically just jumping to the end of this if statement, and because I have nothing afterwards, the compiler generated a no op because there's nothing to jump to. So I need to make something to jump to. So yeah, this basically just shows that we're putting 1 here. Now let's do something different. So if I say array and then as an object, now we have no idea what the heck the type is. So we're obfuscating that from the compiler. So we're basically forcing the compiler's hand to try to figure this out at runtime. So once we see this, then we'll see the code here, and then we'll jump into the actual runtime to see how that code works. And great, I just found a bug in the programming language. So I'm actually going to fix this and be right back. All right, so I fixed the bug. That was pretty interesting. So if we go back to the if statement here, now that we don't actually know what the type is, we actually have to execute this source code. So it's on line 10. So we can see here that at line 10, basically what we do is we say move I of 1, and we check to see if value is, and then we print out this. Now I'm putting this weird value. Hold on, give me a sec. I'm going to fix this right now. If I say int 32, this is just a printing error. It's just not printing out the right value. Basically what we're doing is we're checking to see, so we're getting the value of the object that we want to assess. We're then putting the value of the result of whether or not it was true into the EBX register, and we're checking the either class or type that it is. So considering that class values go from 0 to, whatever the max limit of classes is, basically what I do for normal values is I do negative, whatever, right? So if I say -1 or -7, and I do that because it allows me to use this instruction both ways. So I'm going to load file system J. Yeah. So we can see here that it's printing out -1. So this is basically just the type of, or the specific value for the int 8 array type that we're casting against, that we're checking against. So that's kind of how it works. And then of course I put EBX in the CMT for the if statement, and then the CMT register is what the jump not equal to instruction uses to discern whether or not to jump. And that's pretty much it. So let's look in the actual source code. So if we go down to the virtual machine, we look in the thread, and I think it's actually the last instruction. So obviously, every time you create a new instruction, you have to go through this process. So actually, let's do that first. So here, if I now switch it back to the VM, the process that I go through every time when I add a new instruction is I basically have to go to the opcode section. So if I scroll up to the opcode, then in here, I basically have to add the new opcode. So I added it to the bottom. And yeah, so that's pretty much that. I pick whichever class the opcode is going to be referencing. So is it an E class, D class, C class, or B class? In this case, I think this one is, I have no idea. We'll see. But once we do that, then you want to then update the opcode table. So remember to do that. And I basically just add it to the bottom of the list because, that's the easiest way to do it. And that index is again referencing the numeric value of the actual instruction. So when we access that index, we can then access the code for that instruction. And then finally, I have no idea what the is function is. Okay, so it's at the bottom. So you want to create an is function. Oh, okay, so this is a double-sized instruction. So I pass in the out register, the result register that we want, and then the type, which, can go either way, positive or negative. So I basically just put the values in. So the format of the first instruction is a D class. So I say is, and then I put the out register. And then the second is the type. And I'm doing this because I'm actually working on increasing the size of classes. Now, I'm not going to make any promises. I am going to try to get this in by Wednesday. But right now, the programming language has a limit of 262,000, whatever maximum classes. And I think that number is just a little too low. I know that seems kind of ridiculous, but I have the ability basically to increase classes all the way up to 8.6 million, whatever. And that's what I'm going to try to do. So I'm going to try to get that in. I will mention it in Wednesday's video, whether or not I got it in, but yeah. So now let's actually look at the thread system. So once you go through that entire process of creating the opcode, then you just want to scroll all the way to the bottom and just add it to your opcodes list. So for the is, it's very simple, guys. Literally, I just say register at DA because, again, this is the first part of the instruction. And then I get the second part by saying PC plus 1 and dereferencing the pointer to get the actual value. And then I pass it into the is type function. So I pass it also the pointer, which if you guys remember, every time when we say like move local or whatever, every time we access a field, this pointer is going to be populated. And then I'd BRH increment two instructions because that's how big the instruction is. So for checking whether or not it is a specific type, basically what you want to do is you want to check to see if the type is a var, right? So I had to make a couple changes to the actual sharp object, and we'll see that in a second. I added this new field called nType to the sharp object. Now, as you know, I have been very careful with the size of my actual sharp objects because I want the size of the sharp object to still be 32 bytes. Luckily, it is still 32 bytes. I have no idea how, but I have not increased the size with adding this field. And I didn't want to put it in here because then I'd have to shift these bits around and that's just too much work. So I just added this new field called nType. And what this basically represents is the type of the numeric value it is. So right now I have this type flag inside of the info, but the problem is that this doesn't hold enough information. So I have all these bits for the class address, but basically I'm using this for whether or not it's either a data structure or a var. It's a very simple type that, tells the runtime system, which one of these things to access. So I didn't want to modify that, so I just added this one, and this is going to be 4 bytes wide, and it's going to hold all the various different types. So what I did was I went to the actual compiler. I went to the back end. What is it? No, it's actually here. So I went to data type. And if you guys remember, this is a basic enum that I use for, differentiating the types of numbers and other things in the compiler. So I literally just copied this. Now, I basically have these type of types. So I have from int8 to uint64, which is from 0 to 7, which is 8 values. And then the 8th value, both function pointer types and var types are both considered vars. I basically just default the 8th value to a var, basically. So that's kind of how I do it. So if I go back to the virtual machine, once you create that field, then you're going to want to, when you actually check the type, check to see if it's a var type. And if so, then we're going to check each of these values. So if you guys remember, because classes can have a range of addresses anywhere from 0 to, whatever the max is, that doesn't really give me the ability to actually fit all the information in here. So I use negative values as well. So -1 represents int8, -2 represents uint16, and so forth. So you can basically just add all these values to a negative value. So you guys can pick whatever numbers you want. Just make sure it all fits inside of 4 bits. So I think the maximum you can do is, what is it? See, so if we go here and put all these values, the maximum value you can have within 4 bits is 15. So you should be able to get all of your types in here. And for, int 8, it's based on the actual values that are inside of the data type. So yeah, and actually I can just say int 8 here and, put all of the numeric values of each of those types in here specifically, so we don't have to worry about it. But I just wrote the numbers, so that's what I did. Now, if it's not a number and you want to check for it being a class, it's pretty simple. You just call this class check here, where you pass in the info and you and it to the actual class mask to get out the class address from the actual info of that object. And all you want to do is literally just check to see if the class's address is equal to the type that we're passing in here. So, and that's pretty much it. So that's kind of how it works. And obviously, if the object is not, if it doesn't have a value, then we're just going to throw a null pointer exception. And if we don't get into here, like let's say we pass some weird type that, doesn't exist here, then we just return 0 as a fallback. So that's pretty much how it works. Fairly simple. Of course, if you guys have any questions, you can always put them in the comment section below. And that's going to be it for today's video. So like I said, look out for Wednesday's video. There's going to be a video on Wednesday where I kind of talk about the release and everything. So hope you guys enjoyed the video. As usual, if you're new to the channel, definitely consider subscribing. And till next time, see you guys later.